years ago, I built this box to help me test different capacitors in my guitar's tone circuit without having to resolder it every time. Today, I'm going to show you how I built the better version. So the first thing we need to do is lay out where all our parts will go. I'll show you that I got some different terminal blocks this time. These are probably intended for something much more heavy duty. They can carry some current, but that's not what I chose them for. They're super easy to get at the terminal lugs and actually stick the capacitor leads underneath. I went with blocks that have 6 positions. I learned my lesson. I don't need 12 spots for caps. So I think the plan is going to be to run them the other way. Instead of side to side, I can get them further apart and have a little bit more room to fit the capacitors in place. I have a capacitor and we're going for something like that. The legs of the cap reach out and they'll be easy to get under the lugs. So anyway, the terminal blocks are going to go something like this, and then we're going to add our 6-position rotary switch up here somewhere, and then, as I said, we're getting extra fancy. We'll put an LED in front of each position so we know which cap we're using. All right, let's get started. So the first thing I'm going to do is lay out the rotary switch, mini toggle switch, and all the other holes we need to drill. I just made some quick location marks and I made a note to myself so I remember what size hole to drill, the rotary switch and the little mini toggle switch. The rotary will choose the capacitor and the on-off will just turn the LED system on or off. I'm using a step drill to drill the larger holes just because I'm not sure what kind of plastic this is and I just don't want to blow it out. So if you've never used a step drill, it has incremental hole sizes and you creep up on the size you want, drilling a slightly larger hole each step. So 3/8 is the 3rd step. Just want to make sure I don't overshoot it. Perfect. The mini toggle requires a 1/4 inch diameter hole. You may have to do a little adapting for your own case, but the terminal blocks that I have, if you look at the interior of the cavity, it's very tight and it has these lugs in the corner. So I need to know exactly where to place the holes that are going to hold this in place. You do your thing, but I'll show you what I'm going to do. So what I did is I drilled one hole as tight as I could in the corner, and I fastened one corner, and it looks like the other side is just going to be slammed up against the outside of the box. This box is just big enough for this terminal block. There, that worked perfectly. There's room for 4 screws, but I think 2 will be fine. Okay, next thing is to place the second one. I thought I would just temporarily mount the switches to make sure they don't interfere when I put the LED bezels in place. What we want to do is be as far away from this terminal block as we can be. So the capacitors have plenty of room to run across here, but we don't want to crowd these LEDs. Yeah, I'm going to say that looks good. So we'll say that that hole is 2.5 inches from the end. Do the same thing that we did last time. We'll mount one side. I'll end up taking this back off to drill the holes for the LEDs. This will help us figure out just where it goes. So let's see where these bezels might go. We can still get to the switch. Now, take this block back off again. Now I'm going to pop this back on because I want to know where the center of each of these terminals is. It's not super important. It'll make it look pretty. I need a 5/16 hole for the bezel holder, but start with a smaller brad point drill bit, and then I'll switch to the step drill. Perfect. All right, just for fun, let's pop a couple of bezels in here to make sure they fit. All right, looks good. Now we need some wire channels to run through from the terminal block to the rotary switch. I'll go with a tiny little drill bit. We'll test and make sure it fits our wire. Perfect. 5 more. And we're going to tie all the grounds together on this end. So we need one more wire channel there. Alright, I think I'll install the rest of the bezels, but first I'm just going to do a quick tidy up because I'm getting dirt stuck in everything. Those are super tight, but they fit. They look okay from the outside though. So we're almost done with the assembly, but let's put everything back together that we can. All right, so I think we'll wire up the on-off switch before installing it in the box because it'll be a little bit tight inside the box. So when we go from the switch to the power supply, in this case a 9-volt battery, we need a resistor so that we don't blow up the LEDs. So we'll share one resistor with all 6 LEDs because only one will ever be on at once. Hey, I just wanted to take a second to remind you that solder fumes are really bad for your health. Always use a fan when you're soldering. The little one you see me using in the video even has replacement filters, and they're both really affordable. Get yourself one. Okay, back to the build. All right, now we'll attach a short bit of wire. This is 24 gauge wire, so it's pretty teeny, and it happens that this wire is not pre-tinned, so I'm just going to tin it. Okay, so that's our resistor in place, and just out of sheer paranoia, I like to test along the way, because if you get to the end of your project and something doesn't work, it's easier to find the problem if you find it along the way. So let's just bare the end of this wire, hold this. We're good. All right, so I think we can install this guy in the box now. And we don't really care which way is on or off, so it doesn't matter which way we put it in. So I went with sideways inside here, just because it's easy to get at the lug. And that gives us a side-to-side on-off. So now we need to connect our power switch to the rotary switch. I won't go into super detail. This rotary switch has 2 6-position switches that share the same knob. So when pole number 1 is set to position 1, pole number 2 is also set to position 1. So one will drive an LED and the other will connect the cap, and we'll know which cap we're using in our circuit. I think I'll bring my helping hand back for a minute. All right, so the plan is to tin the end of this wire just a bit. So these LED bezels have little plastic inserts that help snug the LEDs in and let them peek out just the right amount on top. So once we get those in place, they're a little bit tough to work around, but what I want to do is actually attach some lead wires to each LED before they're in the box, and it's hard to get my fingers in there. So I just want to measure where I would clip the leads to attach a wire. That's the LED with the little plastic thing that snugs in the bezel. The longest leg on an LED is the positive lead. That's the one we're going to attach some wires to. So I think if I were to snip them about there, that's probably good. I'm going to keep a few of these leads that I snip off for later. So now I'll do that to the other 5. making sure I always clip the longest leg. Try to make them all about the same length. So I've got a wire on each of the positive legs. We'll run those to the rotary switch in a minute, but all of the negative legs I'm just going to tie together with a bare copper wire. So this is also 24 gauge, just like these 6 colored wires are, but this is solid core, so it's not made up of strands. It'll make sort of a ground bus. So let's just check to make sure that all solder connections are good. Better to find it now if they're not. So I'll touch one end of the ground bus that we've installed, and then I'll touch each one of the negative LED leads. All right, we're good. So I'm going to snip some of our ground leads now, just to make it tidy. These things want to fly everywhere. I think I'll leave this here for now to connect to the battery snap. So our next step is to take the positive lead from all the LEDs and connect to the rotary switch. I normally like to keep red and black for positive and negative from the battery, but my wire selection has 6, including red and black, but it should be easy enough to keep it straight. So let's tin the ends of these 6 wires. I like these helping hands. They're long. This one, it's a heavy metal plate, so it doesn't tip over. Now we're ready to solder the switch. So remember, a rotary switch has 6 positions, but it actually has 12 of these lugs. So wherever the knob is set, the opposite ones are active. So we just have to remember, if we put the blue wire from that LED here, we pull the same wire from the cap to the one on the opposite side. And I realized that there's actually a stop in this one. So there is very definitely a lug 1 and a lug 6. You don't have to make a hook to make a mechanical connection with a lug, but it helps a little bit. These are great. They're like little rounded cones, so they're perfect for forming the ends of wires around. This is one of the poles out to our on-off switch, and I'm just going to tuck the wire in so that I don't accidentally touch it with a soldering iron and melt it. That is all 6 of our cables. Alright, so each of these 6 wires from the LED and the lug that I've soldered them to, as I turn the knob, I'll eventually find one that's connected to this output wire to the on-off switch. So what I'll do, I'll put my multimeter in continuity mode, and I'll use one of these little alligator extensions so I don't have to hold it with my hand, and I'll clip it on the wire coming out of the rotary switch. If I touch one of these wires, Haha, I was lucky. The first one I touched, this blue one, is where the knob is set. Well, I guess I'll install the knob to make it easier to turn. All right. So let's go back and test. That's blue. Now the LED side of our switch is wired and complete. So before we add the battery snap, let's just do a quick battery test and see it all lit up. So I've got a 9-volt battery and my 2 handy dandy alligator clips. So what I'll do is grab the negative side of the battery, and this is why I didn't snip my ground bus. And then the other side of the on-off switch is what's going to run to the positive terminal of the battery. Our on-off switch turns the LEDs on, and as we rotate our way along, it's going to show us which cap is which. So now all we have to do is be careful that we wire this terminal block with the same color wire and to the correct lug that we used on this LED. So let's do that. All right, so let's start at this end. We've got a blue wire on this LED. Now before we start, we'll confirm that's our blue lug. And so we will make certain that this free lug is also position blue. They're numbered, but we'll use colors. And there's our first one. Okay, so now it's time to bring our capacitor wires up through the box and to the terminal block. So remember, we have to match the color blue capacitor to blue LED. That way the LED tells us when this position is on. And I don't think I'm going to bother tinning these because they'll be pinched down solidly by the terminal block. These are sometimes called barrier strips because they have these dividers in between. These dividers are what's making it difficult to get my fingers in there right now. Now that we have this end of the terminal block that will lead to the tone pot in the guitar, we need the other end of the cap, which would go to ground in the guitar. We need to tie those all together and create a ground wire that you'll attach somewhere in your guitar circuitry. I'm going to use some solid core wire again, but this will just be easier to route. I'm just going to peel off a bunch of the insulation. Let's try that. So I'm just looping it from one terminal to the next. It sticks out the back a little bit, but that won't be a problem. And there we go. We have one end of our cap wired to the switch, and one end of our cap, or our row of caps, is tied together on a ground. So now we need a way to get those both out to your guitar circuit. Here's a typical capacitor, and you'd have this in your guitar. One end would be attached to one of the lugs on the tone pot, and the other end would be grounded somewhere in the circuit. So we're adding as many as 6 of those in our project box here, but we still need some way to attach the box to the same guitar circuit, the same tone pot lug and the same ground inside the guitar. So what we need is a length of wire from the ground end here that we've tied together, and we need a wire from the other end that will go to the tone pot. And remember, that end is selectable by turning the knob on the switch, so we need to take the output of the switch to do that. It'll make sense in a second. Let's do that now. So we tied all the grounds together. So I'm just going to use a wire from any one of these because they're all the same. We'll run that in the box and then out another hole just so we can run it with the same wire from the other end. Let's use this one. We'd be smart to test a few things here, so let's just strip a little bit on this end. Get our trusty meter. So what we want is the end of this wire to be connected to all those grounds, and it is. And if you remember, we drilled a hole to bring it inside the box here. So that takes care of our ground. Now we'll work on the positive end. This is the last available lug on our rotary switch. It's our output. So before we can use these, we need to add some power so our LEDs work. So just like any stomp box, you could add external power with a power jack, but the easiest way to get off the ground is just to use a little battery snap like this. So the negative side of our battery snap wants to go to our ground bus, and then the positive side goes to the other side of our on-off switch. Okay, so to do a quick recap, our rotary switch has two positions, so it's like two 6-position switches with one knob. And if you see here, I've separated the two sets of circuits. These I've bundled together just temporarily. They're all the leads from the LEDs. And these that I've bundled together are all the leads that go through to the top to the terminal block. So let's look at the LED circuit first. So basically, all the grounds are tied together and lead to one side of the battery snap. And all the positive sides lead to the switch, so we get to choose which one is active. Whichever one is active comes out of the switch through this resistor, which is to keep from blowing up the LEDs, through the switch, and then to the other side of the battery snap. So the switch interrupts the flow of power. And when power is flowing, it comes through the resistor to whichever LED we've selected. So that's half the switch. And that has nothing to do with how the capacitors work. That's just so that we know which capacitor is active. The other side of the switch, each of these terminal blocks on the other side come from one end of each of the capacitors and into the switch. And whichever capacitor we've got the knob set to comes out this long red wire. The other end of every other capacitor is tied together on the ground line, so these are like the leads on either side of the capacitor, except we select which capacitor on the box we're using. So now it's time to do a quick test. Let's start with the LED side of things. So we'll pop the battery in place. And you can use a battery snap and a little bit of double-sided tape. In the parts list, I'll give you a link to a proper battery holder. With the battery in place, cross our fingers. Our on switch is on, and our knob should 3, 4, 5, 6. So we have an indicator as to which capacitor will be coming out here once we get this side tested, but this is working perfectly. We need to drill a hole in the end of the box to get our two lead wires out. Just aim for center. And I just tied a little loop in the wires here. That's just so that if we get a little crazy and tug on the wires, we won't pull them out of the switch. So there we go. Why don't we get our meter and test that side of things? Put the meter in continuity mode. Perfect. Flip the power on. we can see we're on the last setting here. If I were to go from this ground to the ground out, we're good. And if I were to go from the other end to our red lead, we're also good. So you could go through and check each one of these, but I'm pretty confident we're good to go. Now it's time to put a capacitor in here. So let's loosen up a couple terminals. I've just grabbed a paper and oil 047 that I happen to have here. And I'll just cinch it down under the lugs. We test this capacitor right on its leads, we get 4877. So that's close enough to 047. And if we were to test at the other end of our leads, we get 04877, so exactly the same thing. So with the dial set here, these leads at the end of our box are effectively acting like either side of whichever capacitor we have selected in our guitar circuit. One last thing we can do here, and you've got a few options. The leads that come out of the box, we could attach some alligator clips, and that's perfect if you want to just clip it on tone pot and some ground point inside the guitar cavity. I also happen to use this with the breadboard when I'm working on electronics projects. What's handy there is I've kept some of those leads that we clipped off the LEDs, and if you solder those on the end of a lead, they'll push into a breadboard. I'm going to go with that option. So what we need to do is wrap some wire around a little piece of a lead here. And then we'll solder that. We'll just add a little shrink tube to make it look a little prettier. There we go. So these will push nicely into a breadboard, and when I want to use it to test a guitar circuit, I would use my little DIY alligator clips. Clip one on here, clip the other end in the guitar circuit. So it kind of does double duty. Let's button up our box. I don't have the battery taped down, but we'll take care of that later. We need some capacitors. I've got a shopping list of options here. So I have a handful here. We can do up to 6. Here is an 022, an 033. That's another 022. So let's put our 22 in next. So all we do is loosen up the terminals. Alright, I've got drawers full of ceramic caps and chiclet caps, but we'll load those up later. But one thing I will show you, we grab some solid core wire, take up one of our positions with a piece of bare wire, and that will be our bypass. Like a true bypass in a stomp box. Alright, before we test it in a tone circuit on a guitar, I thought I would show you why I choose to add leads that I've clipped off of some other component to the end of my wires. And that is because whenever I'm doing any sort of circuit tinkering on a breadboard like this, these are just perfect to push in anywhere you want them. And now, in this circuit, I have any of these capacitors that I can test in the circuit. It's awesome. Here's a shop guitar I keep handy. It's desperately in need of some TLC, but it'll be a good guinea pig to test our new capacitor Choozomatic flux capacitor. We need a name for this thing. All right. You'll see 2 caps in here because I did an Esquire wiring with a 4-way switch, but our main capacitor is here. So I'm not too worried about how he's wired, so I won't gently remove this cap. Let's just snip him right out of here. So that's the tone pot, and here is the ground. So what we'll do, bring our project box into the mix, put the ground wire where the ground was, put the live wire on the tone pot. So you can see that our new project box sits exactly where the capacitor was. It's acting like a capacitor. We just get to choose the one we want. So let's turn it on and let's flip right over to the wire so we know we're in bypass mode. So that's with no cap, so this tone knob should do nothing now. And our volume is still our volume. Let's start at one end. So that's the 047. Who's next there? What you'll notice is some values just get muddy when they're turned right down and they're not super usable. But anyway, that is the magic of our new Capacitor Choose-O-Matic 3000 box. So let me know if you build one of these, and don't forget, I'll put the parts and tools list in the video description, and I'll link you over to my website where you can download the schematic and all the build instructions that'll walk you through everything I did here. When you finish building your Cap Tester box, check out these templates that you can use on your next build.